Now let's understand about the overfitting and underfitting concept, because it is very very important that any machine learning practitioner should know about this thing, right? What is like overfitting and what is underfitting. So I'll give you one basic scenario. Okay, now suppose that in your company, on your teammate, you suppose your supervisor is basically give a task to three of those friend including you. Okay, so let's say that that one of your colleague is come up with a solution that it's basically a classification solution. So he come up with a solution that, and he has actually given his his model. So let's say that he has given his hypothesis 1. It's his own hypothesis, right? That in this way he wanted to classify these two model. The other one, which is like you have set up the hypothesis 2. So in this way you wanted to like classify the model. Okay, and one more person, let's say some intern. Okay, he came up with the best solution, and he has given hypothesis 3, right? Now your supervisor will come, and he wanted to examine that which of those like model, let's say this is my model 1, this is my model 2, and this is your model 3, which of the model is best. Okay, best in terms of training and testing error both. Okay, then first of all your supervisor will directly reject this model, right? And the new person will get unhappy and ask like, boss, why? Because I can easily able to separate my model, right? Separate your data. Like, then why did you rejected my this model? Then he will tell you that this model is basically, though it is classifying the class A and class B label very very well, but it has, let's say, training error 98% because it is classifying well, but it has a testing error somewhere around 30 to 40%, which is very bad, right? Because once you already set up the model, right, and suppose if your testing data contain any kind of a outlier, something like this, right, where somewhere star is something like here, okay, or let's say my circle is here. Okay, now you, once you trained your model, you cannot mold your model and tweak this equation, right? Because it is already trained, right? And after training you cannot tweak this part. Okay, so in this way the model will perform worst, right? In terms of testing error. Okay, so that is why it will simply reject it, and the boss will tell you that, okay, this is basically your overfitting model, the model is overfit. Okay, you need to come up with some more equation. Then he will go to the person 1. Okay, your colleague, who is like your very much favorite, right? He wanted, now he has actually come up with your solution, that he is telling that this is my hypothesis 1. So the boss will tell that this is also a kind of very low accuracy model. Why? Because first of all he will tell that the your hypothesis itself is very very worst. Okay, like, and he will tell you the reason as well, right? Because as you can see that this line, though it is classifying some part of this and some part of this, but it is not classifying totally, right? Because let's say that for this line the equation is what, the equation would be something like minus of x plus c, right? Minus of x, because this is like the slope is going downwards, correct? Now because some part of the class, some part of this class is actually belonging to this into this class, right? And some part of this class is actually belonging to this part, right? And he will not be very happy, right? So now, so in this way the model is basically underfit, right? Because your training and testing also very low. Your training error is also very low, and testing error is also very low, right? Accuracy, training accuracy is also low, and testing accuracy is also low. Then he come up to your desk and tell that you may improve your model, but I am happy with this hypothesis, by your hypothesis. Again, you come up with a lot of hypothesis, right? And he come up with this hypothesis, which means like he come up with this, like y is equal to minus x square, right? And boss can tell that you can just tweak a bit, let's say y is equal to minus x square plus c, and he can just do like this, right? He can just like move the curve like this, and in this way he will get a very good accuracy. So he will get, let's say, training error 85%, and testing error is also, let's say, 80%, and he will be very happy because his model is not either overfitting and not underfitting. So this is just a distinction between like what is the overfitting and underfitting. Okay, when is the overfitting happen? When your training data is much higher than your testing accuracy. And when this underfitting will happen, so when your like training and testing accuracy is very very low, okay, which I don't want as a machine learning practitioner. So I will come up with this, or like a very mediocre solution, and it is my responsibility to make the mediocre hypothesis or a model into a best possible model by tweaking or tuning the parameters. So later I will tell you the difference, like how do you actually do the hyperparameter tuning and other thing. Okay, so I hope you get this difference. Again, the same thing, this is actually underfitting, so this is actually good fit, and this is actually the overfitting, because I am touching every, let's say, point which I don't want, right? So this is just a difference.